We, the students of Chemical Engineering from Vishveshwara National Institute of Technology, are here to demonstrate and show the application of mass transfer in day-to-day life. The best example of mass transfer in day-to-day life is the functioning and working of an evaporative cooler, which works on the principle of evaporation and humidity.
An evaporative cooler draws hot, dry outside air through wet pads, and as water evaporates from the pads, the air temperature drops, and cool air is blown into the house. Because evaporative coolers operate best in dry climates with low humidity, evaporative cooling has two important advantages over air conditioning. An air conditioner doesn't blow fresh air. It just recirculates stale household air over and over. But unlike an air conditioner, the evaporative cooler constantly draws in fresh air, and when that outside air passes through the wet cooler pads, it doesn't just get cooler, it gets cleaner. Because the wet pads filter out dust and pollen before the air goes into the house. Homes equipped with upducts ceiling vents receive the added bonus of lower attic temperatures. The second advantage over air conditioning is energy savings. Because a cooler uses much less electricity, hundreds of dollars a year can be saved.
Evaporating cooling is the process by which the temperature of a substance is reduced due to the cooling effect from the evaporation of water. The conversion of sensible heat to latent heat causes a decrease in the ambient temperature as water is evaporated, provided useful cooling. Effective cooling can be accomplished by simply wetting a surface and allowing the water to evaporate. Evaporative cooling occurs when air that is not too humid passes over a wet surface. The faster the rate of evaporation, the greater the cooling. When considering water evaporating into air, the wet bulb temperature as compared to the air's dry bulb temperature is a measure of the potential for evaporative cooling. The greater the difference between the two temperatures, greater the evaporative cooling effect. Evaporating Evaporative coolers provide cool air by forcing hot dry air over a wetted pad. The water in the pad evaporates, removing heat from the air while adding moisture. When water evaporates, it draws energy from its surroundings, which produces a considerable cooling effect. In the extreme case of air that is totally saturated with water, no evaporation can take place and no cooling occurs.
117, but I didn't stop it and